to take this thing and write it as t of x. Come on. So t of x equals what? X plus I, x minus I. Okay, so that came from that. I'm going to tell you, you've got I as a 0, then its conjugate is also a 0. And then we've also got x minus 1 plus I and x minus 1 minus I. And that comes from that there. All right, so the next thing you're going to want to do, you start multiplying these things out. Now, my suggestion to you, because it's all multiplication, and we got 4 objects there you can multiply, so you can do them in any order that you want. You can flip them, compare, associate them any way you want. But hopefully it makes sense to group the black ones, right? Because they're conjugates. And then we can group the red ones. Now, the red ones may not seem to be conjugates to one another, and then they're not. This, for instance, oops, there we go. That term there, okay, if that was a plus, okay, and that was a minus, and that was a plus, and that was a plus, then we would have conjugates. And maybe, what happens if I distribute? Yeah. We don't get these are not conjugates, okay? Even though this portion here and that portion there are conjugates, the 1 minus I and the 1 plus I, when I go x minus those, that does not create conjugates. Does that make sense? So everything I've got written in red are not conjugates. But it does make sense to multiply those together. All right? It's real nice to multiply these together. So we get x times x gives me x squared, right? Now, I times negative I gives me negative I squared, which, what's negative I squared?
Positive 1.
Positive 1. Okay? So you get x squared plus 1. All right, now, we've got some options when we work over here in the red stuff. Okay? And we can do this 2 different ways. I'm going to do it maybe a way that most of us probably maybe don't feel extremely comfortable with. Okay? If I go first times first, it's x times x, right? So it gives me x squared. Okay? And then we go outside times outside. All right? So it's going to be outside is this negative 1 minus I, right? A negative quantity then of 1 minus I. And then times my x. So it's going to be minus x times 1 minus I. Okay. Now inside times inside is going to be the same thing. So it'd be negative x. Okay. Now I guess it's not the same thing because it's 1 plus I instead of 1 minus I. Okay. Is that okay with everybody? So I'm doing the multiplication. I'm just not multiplying it out, right? I'm implying that I'm going to multiply that that term there times that term there. Okay. So multiply my inside terms together, and I write it down like that. Now, last times last, I'm going to, again, imply the multiplication. Negative times a negative is a positive, right? And then I'll have 1 plus I and 1 minus I. And that's what that red stuff comes out to be. Okay? Now, as I go through, and I'm going to simplify that red product. I'm really struggling here with my cursor not wanting to show up. All right. So the black stuff is still x squared plus 1. I haven't dealt with that yet. But now with the red product, that's going to be x squared. We then have minus x plus xi minus x minus xi. Okay, so just distribute that stuff through there. Then I'm going to distribute that stuff through there. And now we'll come over here and we'll multiply these together. Well, those are conjugates again, right? So 1 times 1 gives me 1. And I times negative I gives me negative I squared. What's negative I squared? Positive 1. Okay? So it's going to be x squared plus 1. We then have x squared, minus 2x. And then the xi and the negative xi cancel out, and I got plus 2. Okay? So what this tells me right here, if you were to factor that, you have to use the quadratic formula to do this. Okay? You should end up getting x is equal to 1 plus I and 1 minus I. Okay? That quadratic is where these two zeros would come from. Is that doable? All right. So you can start to see then that we simply have a binomial times a trinomial. So I'm going to distribute the x squared plus 1 to this. So you get x squared times x squared is x to the 4th. X squared times negative 2x gives me negative 2x cubed. And then x squared times 2 gives me 2x squared. I'm going to distribute the 1 then, gives me positive x squared, minus 2x, and then plus 2. Combine your like terms. So I get x to the 4th minus 2x cubed plus 3x squared minus 2x plus 2. So there's my t of x. But I have not answered this in the format that they were interested in. Okay? Because they said that my constant term had to be 16, right? What's my constant term right now? 2. How can I make that grow into a 16? Yeah, multiply 8 by 8. But I got to multiply everything by 8, right? So I have 8x to the 4th minus 16x cubed plus 24x squared minus 16x plus 16. And there is the t of x that we're looking for. Okay. Yeah. Right, because up here they tell me that I have to have a constant term 16 in the directions. So when I do all the multiplication, I just get a 2 over here as my constant. So I need to change that to. And the only way we can change those, whenever they ask you to specify what a certain coefficient has to be, the only way you can get that is through multiplication. Okay. If you were to graph this, you would see that you have a 4th degree polynomial that never does what? Never touches the x-axis, right? Okay. You've got 4 imaginary zeros or complex zeros. That means this thing's going to be kind of looking probably most likely like a W almost. Okay, but it's going to be all above the x-axis. This is really hard without seeing where my mouse is. Does that make sense? All right. You could. I've been kind of toying with the idea of showing this to you, but let's show it to you. Let me write this down real quick. We're looking at u of x to equal, that's a 0, so x minus a half will be a 0, or sorry, a factor. Negative 2, so it becomes x minus negative 2, which is plus 2, is a factor. We've got x minus a negative I, so it becomes plus I, right? And then you've got x minus that conjugate, which would just be I, right? So x minus I. Okay. When you see, and this is something that people have struggled with in questions like 101, when you see negative I, that is really 0 minus I. And then its conjugate is 0 plus I. And if you go ahead and plug in x minus 0 minus I, like that, right? That's my factor. Distribute the negative, you get x minus 0 plus I, right? Well, you're going to write that as x plus I. That's the most logical thing to do. So that's 4 factors, and we go through, keep reading this, and it says 0 of negative 2 as a multiplicity of 2. That means that I need another factor of x plus 2, right? So I'm going to write it this way. Put an exponent there. And now I'm going to go through and start multiplying things together. Now there's 5 things, right? When I FOIL, I can initial foiling, I can only multiply 2 times 2, right? 2 objects, okay? So I'm going to actually FOIL that one out first. So x minus a half. And now x plus 2 squared gives me x squared plus 4x plus 4. I just find that to be an easy thing to do, okay? And I also find that the conjugates here of x plus I and x minus I are an easy thing to do. So x squared, it's going to give me minus I squared, right? Well, minus I squared becomes plus 1. Going from there, I don't know which ones are going to be easier to multiply together. I'm just going to go ahead and multiply those two together. I see that negative 1/2, and then I see a bunch of even numbers over here, right? So that multiplication would probably be pretty simple. So x times x squared gives me x cubed. X times 4x gives me 4x squared. X times 4 gives me 4x. Then we get negative 1/2 x squared. Then I'm going to get negative 2x. And then negative 2. So there's that. And we still got my x squared plus 1. If you want to combine stuff now, you can. Doesn't really matter when you do this. We got 4x squared minus a half x squared. So that's what? 7/2 x squared. So plus 7/2 x squared. 4x minus 2x gives me 2x. And then minus 2. And now I've got x squared plus 1. So now I'll distribute the x squared plus 1 of this stuff. So x squared times x to the third is x to the fifth. X squared times 7/2 x to the squared is 7/2 x to the fourth. And then 2x cubed minus then 2x squared. And then plus x cubed plus 7/2 x squared plus 2x minus 2. Combining like terms here, x to the fifth plus 7/2 x to the fourth. We've got 2x cubed here and x cubed there, so that's 3x cubed. Negative 2x squared plus 7/2 x squared, so that's 3/2 x squared. Okay. Knowing that this was, that's negative 4/2, right? Negative 4/2 plus 7/2 is a positive 3/2. I did the x cubed. Should be then plus 2x and then minus 2. There's my u of x. Okay. Now if I match that up, see if that matches to the exact same thing they started me with, and it does not. Okay. And I don't know that there says degree 5, leading coefficient. Okay. There, I glazed over that. The leading coefficient needs to be 4, right? Okay. So I come down here, leading coefficient. That number right there is a 1. How do I make that number a 4? Multiply by 4. So I multiply by 4, 4x to the fifth. This is going to be then, what, 14x to the fourth. That's going to be plus 12x cubed plus 6x squared plus 8x minus 8. And that does end up matching with what they asked me for. Okay. On like a handwritten test or something, that leading coefficient statement will probably be there. Because just think about, like, I don't know if I said this in your class yesterday or in the second period. Think about how when I would grade 45 tests, let's say this is question 3 on that test, that we can our quiz and take on Monday. When I want to go grade something, I don't want to grade it 45 times. I don't want to have to look through and find a bunch of fractions. I don't want to say, okay, this person has a 1, a 7 halves, a 3, a 3 halves, a 2, a negative 2. And a lot of times even the fractions get more complex than that. But it's a lot easier for me as I get through like the 10th, 12th page or test. I have memorized 4, 14, 12, 6, 8, and negative 8 in that order, and I can quickly start grading the rest of those. Does that make sense? And that's one of the reasons why on paper pencil tests you'll see that weighting coefficient requirement. On this, why you see that is because it's a lot easier for the programmer that's coding WebAssign to match coefficients and type in coefficients to match than it is to develop an algorithm that's going to match fractions. Does that make sense? So that's the necessity of that coefficient. Hopefully we realize that either this blue line u of x here or this red line, they provide the exact same zeros. It's just that the y values for the red one are all 4 times as large as the y values for the blue one. Okay, because of that multiplier out front, that transformation. Any others we want to do? We're not doing anything else today other than this, so. And it does seem kind of like those two do take care of a lot of the other type of questions, right? Number 8. All right, so they're giving you, so it's 2 degrees, so it's going to be quadratic. We're going to go x minus the 1 plus I radical 7. And then x minus the 1 minus I radical 7. And we can actually do this 2 ways. The first way is that I would really just kind of focus, even though this is a quantity here, kind of visualize those two things that are yellow as just one object, okay? And actually kind of visualize it as maybe maybe a variable or something like that, okay? And do your multiplication, your foiling, with that. So what I'm going to do, I'm going to go x times x gives me x squared, okay? Now, if this thing was, let's say this yellow stuff was just r, okay? And that one was r. When I go first times first, give me x squared. Now, first times last, okay, would give me x times r, right? Okay? But instead of calling it r, what if I just call it, and it'd be minus, I guess, because there's negative out front. Wouldn't it be negative x times r, but r is 1 minus I radical 7. Does that kind of make sense? So just write the implied multiplication. Don't do the multiplication yet. Just write down what you're going to do. And that may be kind of how you were taught early on. I don't know. But when you were foiling stuff like x plus 3 and x minus 4, you might have been taught, x times x, right that way. Plus then negative 4 times x. So negative 4 times x, right that way. Plus then 3 times x. And then plus then 3 times negative 4. And write all that down and then simplify, right? Okay. Doing kind of the same thing here. We're not trying to do that multiplication in our head because we're going to make mistakes. So I would write it down first. Now I'm going to go and multiply the inside term. So it's now a negative yellow thing times x. And now I'll do the last times last. So it's a negative times a negative, so that's positive. And then it's yellow thing times the other yellow thing. So that's one way of approaching it, okay? Now let's just simplify. So I get x squared. I'll distribute my negative x, so negative x plus xi radical 7 minus then x minus xi radical 7 plus then over here when I multiply these two things together, these two things are what to one another? Conjugates, right? So first times first gives me 1. Last times last gives me negative. Radical 7 times radical 7 is what? 7, right? And then I times I is I squared, right? Which is negative 1, right? So it changes that negative 7 to a positive 7. Now I'm just going to go through and clean things up. X squared, negative x gives me negative 2x. The xi radical 7 and negative xi radical 7, okay, they become opposites, right? They cancel each other out. And you've seen this happen over and over and over again when we multiply these x minus 1 plus I radical 7, and the x minus 21 minus I radical 7. You see, we saw it in either 13 or 14, where the xi components cancel each other out. And that's always going to happen, because if you think about what happens, when we get complex solutions, they always come from a quadratic function that has that real coefficients, right? All right, so that the I portions right now always have to cancel each other out. And then I get plus 1 plus 7 gives me plus 8. So x squared minus 2x plus 8 is going to be that that final quadratic. The reason they give you this question is because the questions after this incorporate, even if the question after might be a 4th degree or 5th degree, but somewhere inside that 3rd degree, 4th degree, 5th degree, it's going to incorporate you to have to do this at least one time somewhere. Okay, so kind of like what we did here. Okay, it's a 4th degree, but you see right there we had to do something like question 8, right? And you see again here, when we multiplied that stuff out, we ended up getting a positive xi and a negative xi, and the I number, the complex, the imaginary number, ends up becoming additive inverses, and they cancel out. Other ways of doing this, okay, there are other ways. Okay, maybe a way that you might be initially a little bit more comfortable with. I don't know if it's any faster or slower in regards to time, but we could take this first binomial and actually distribute that negative through. So we get negative 1 minus I radical 7, and then over here I'm going to go x minus 1 plus I radical 7. And now you got a trinomial times a trinomial, and that just means distribute all 3 parts of this one to all 3 parts of this one. So you're going to get 9 objects here, but we have x times x gives me x squared, x times negative 1 gives me negative x times I radical 7 gives me xi radical 7. Negative 1 times x gives me negative x, negative 1 times negative 1 gives me positive 1, negative 1 times I radical 7 gives me negative 1 I radical 7. And now last times all this stuff will give me negative xi radical 7. It's going to give me positive I radical 7. And then it's going to give me, negative I squared. Radical 7 times radical 7 gives me 7, right? So now I combine like terms, get x squared. There's a negative x, that gives me negative 2x. A lot of times I like to cancel, just cross out the things I've used already. The xi radical 7 and negative xi radical 7 are your additive inverses. You end up with actually another set of additive inverses going this route, the I radical 7 and the negative I radical 7. And then over here, you know that negative I squared is actually going to change to a positive. So now I have plus 7 and then plus this 1, which will give me plus 8. And that's another way of doing it, okay? Totally up to you, the route you want to go. but I do think it's useful to know that there are 2 routes there. I want to ask you guys. I want to show you something real quick here.